Chapter 20, World Climates and Global Climate Change. This is the last chapter for Section 2. It's also the last chapter for our meteorology section. After this, we'll be moving on to astronomy. This chapter will wrap up all of the different concepts that we have talked about throughout the semester already, and it'll look at how the global world is divided into different climates. We'll also take a look at how the climate's changing based on human impacts and other natural events. This first picture here, it's a beautiful view of the Hawaiian Ocean, looking out of the Pacific Ocean, and it's actually from a McDonald's, sat right here in Hawaii. We saw this slide in the beginning of the semester. The slide shows the different spheres of the Earth, the atmosphere, biosphere, lithosphere, and hydrosphere. And we talked about how the Earth had all of these spheres interacting in what we called cycles. We also discussed the terminology for a climate. Climate is actually the aggregate of weather and its extremes. But climate is also the exchanges of energy and moisture that occur among the Earth's spheres. Some of these cycles are called the hydrologic cycle and the carbon cycle. Climate classification is based on both temperature and precipitation. We will be looking at the Köppen classification system, one way to divide the Earth into a bunch of different climates. This classification system uses the mean monthly and annual values of temperature and precipitation to divide the globe. It also brings the biosphere into the classification system by looking at the boundaries of where certain plant associations are limited. This map shows the climates of the world based on the Köppen classification system. While it looks pretty complex, we're only going to be covering the 5 major divisions: humid tropical, dry, humid mid-latitude with mild winters, humid mid-latitude with severe winters, and polar climates. We'll also take a look at what highland climates actually are. One thing to note is that some of the climate classification systems seem to be oriented along lines of latitude, while others are oriented along the lines that match up to different geographic features, such as the Rocky Mountains and the Andes Mountains. Take a look right now and try and guess what climate system New Jersey is part of. The first climate system is the humid tropical system. These climates are winterless and they have warm temperatures, often occurring near the equator. You can see on the graphs below, which are called climographs, that these graphs show annual temperature and annual precipitation for every month of the year. On the bottom x-axis, you have letters J, F, M, and so on. They stand for the months: January, February, March. And on the sides, the y-axis, you have temperature and you have rainfall. The temperature on the left-hand side matches up to the red line across the middle of the climate graph, while the precipitation matches up to the blue bars along the bottom of the climate graph. In the humid tropical climates, you can see that the red line doesn't vary too much, even though in Australia it varies a little bit. Temperature is pretty consistent. And you also don't have a very cold temperature. Even though the temperature does dip down to about, let's say, 70 degrees Fahrenheit in Australia, it's still a very warm climate. Precipitation does vary throughout the year. Another thing to note is that all these lines make a slight smile. The line in Australia makes a much better example of a smile. This shows that your temperature is highest in January and December and lowest in June and July. When these lines of temperature make a smile, it's safe to assume that they are showing locations that are in the southern hemisphere. These are some pictures of examples of humid tropical climates. So very lush and green and a lot of water in these areas. The top right picture is a picture of Hawaii and the waterfalls. These were used as a background for some of the opening scenes of Jurassic Park. And the rest of the pictures are from Fiji, very tropical area, very humid, very hot, lots of green vegetation. The next climate is the dry climate, or B climates. These climates exist in areas where evaporation exceeds precipitation, and there's a constant water deficiency. While deserts are often thought of as areas where water or rain does not occur, that's not a correct definition. Instead, the evaporation exceeding precipitation and a constant water deficiency is a better definition of what a desert or a dry climate is. Besides the arid deserts, we also have semi-arid areas, which are called steppes. Dry climates are often exhibited in areas of low latitudes, and they often occur in the interiors of land masses, such as in New Mexico, where we saw that continental tropical air mass coming up from Mexico that was bringing in warm, dry air, causing deserts to occur. Additionally, they exist around mountain areas. Mountains cause orographic lifting, which cause rain on one side of the mountain and a rain shadow on the leeward side of the mountain, which causes the dry climates. You can see the locations in yellow and in gray on the map where these dry climates exist. Here are the climagraphs of the dry B climates. You can see the lack of precipitation throughout the year. It is very minimal as compared to the previous climates that were shown for the A climates. You can also see that the temperature does vary slightly. It varies because the land can heat and cool pretty quickly, as we learned in the first lab, or the second lab. Also, if you note, these lines of temperature look like frowns. When the lines of temperature look like frowns, that means the lowest temperature is in January and December, highest in June and July, and therefore it's pretty likely that these areas are going to be located in the northern hemisphere. Here are some more pictures of what a dry climate looks like. The background picture is a stick bug walking on the ground in central Australia, and the ground was cracking just like if you put clay inside a kiln. And on the bottom right you can see a picture of Arizona, where the land was just really dry and you had these wind erosion gullies in it. The next classification system is the humid middle latitude climates with mild winters, or the C climates if you want to shorten it a little bit. This is where we live in. So these are very seasonal climates. The winters aren't too cold, but you can get some drastic coldness. Obviously not this winter. And there are 3 different subgroups. This is a wide variety of a category. It's kind of a catch-all. And so it's not very distinctive, and if you actually look back to that first big world map, you see that it's split into these 3 categories. But we're not going to worry about that. We're just going to worry about the C climates. And 3 subgroups are humid subtropics, marine west coast, and dry summer subtropics. You can see the variety of temperature and the variety of precipitation throughout the year for these climates. Again, if you note on the climograph, the left 2 figures have temperatures in the shape of a frown, so therefore they're in the northern hemisphere. Whereas on the right picture, the temperature is in the shape of a smile, being Cape Town, South Africa, and so it's in the southern hemisphere. It's very hard to pinpoint a picture or so on a slide for the sea climates because there's so much variety within them. So these three pictures just kind of try and capture the variety that can exist in the sea climates. Picture on the top left is actually the Rio Grande in Texas along the border of Mexico. Next we have the humid middle latitude climates with severe winters. One thing that is distinct about these is that there is year-round precipitation, and they're colder than the sea climates. Interestingly, they only occur in the northern hemisphere, and there are two groups to this, the humid continental climates and the subarctic. By looking on the climograph, you can see that there's a drastic change in temperature from summer to winter, and there's precipitation throughout the whole entire year. So Chicago, Illinois, and Moose Factory, Ontario, are characteristic of the D climates. You can see there they exhibit vegetation, trees, mountains, glaciers, ice, and liquid water. The next climates are the polar climates. These are really, really cold, and they have very little precipitation throughout the year. We have two types of climates in the polar climates, which are the tundra climates, which are treeless areas that still have vegetation, and ice cap climates. If you look at by looking at the climographs, you can see how far down the temperature has moved on the climographs as compared to any of the other climates. And still there's a great variation in the temperature, while the precipitation remains low to non-existent. Here are some examples of pictures from the polar climates. I didn't take any of these because I've never been that far north or south. Here's an interesting story that I found while I was doing some work online. And this is a story about a race to the South Pole, Antarctica. So there was one explorer, Robert Falcon, and he had an expedition in which he was going to be the first explorer to ever discover the South Pole. And he reached it on January 17, 1912. But when he got there, he found that a tent with a dark flag fluttering above it stood at the very spot of the South Pole. So how did that get there? Well, about a month beforehand, another explorer, a Norwegian explorer, I'm not even going to try to butcher his name, but he had reached the South Pole on December 14, 1911, 1 month beforehand. So he left this note in this monument to Robert Falcon, saying that he made it first. Unfortunately, Robert Falcon and his two men, they actually froze to death on their way back from the South Pole. Kind of a sad story. But it shows how adventurers and explorers were willing to risk their life to go and be the first person to find the South Pole. And this was kind of interesting because there's a new book coming out by an author, David M. Wilson, and his grandfather's brother was on this expedition. And he ended up finding, through a family friend, these photos that never had been seen before from the expedition. So I just want to show them to you real quick. These are some pictures of the expedition moving through the snow. December 13th, 1911. Scott's sledging party pulls one of the heavy sledges through deep snow that an unseasonably warm blizzard dumped on the expedition as the men approached the Beardmere Glacier. The ponies Scott had bought to pull the equipment had sunk up to their bellies in the deep powder and had been shot several days ago before this picture was taken. So this is where Scott was a day before the Norwegian found the actual South Pole. Some people had asked in previous classes, well, how did they know someone was there? Well, this was before the time of texting or Facebook or any way to really communicate. So they didn't know. They knew there was another expedition out looking for the South Pole, I'm sure. I'm sure they knew it was a race, but they didn't know that They didn't know that Robert Falcon Scott was behind him by a month. So when Robert Falcon Scott got there, he ended up being very disappointed by that. And so Scott started learning how to take photography, because when you go on expeditions like this, and I only know about it from reading it in books, but you take a crew with you, and some people don't go all the way. They stay back at the camp, and your photographer would probably be one of the people who wouldn't go that final leg of the trip to see the South Pole. So Scott started to learn how to take pictures so he could take pictures when he was there. December 20th, 1911, 1 month from the pole. This is one of the last images Scott took before his camera headed back to the expedition base with one of the sledging parties. Scott took only 4 men with him on his final push to the South Pole. Scott and his 4 companions perished on their return trip, done in by the relentless grip of the approaching Antarctic winter. Scott Wilson and Henry Bertie Bowers, likely one of the figures seen in this picture, died in a small tent just 11 miles from the next food depot. Searchers found the tent in late 1912 and discovered the explorers' personal effects, covered the tent with snow, and marked the men's resting place with a cross made from skis. Their frozen bodies still lie somewhere beneath the Antarctic ice. So that's just a little sidetrack of what people will do to make a discovery. The last type of Köppen classification system that I wanted to just touch on are called the Highland climates. And these climates are literally when you go upwards in altitude. They're usually cooler and wetter because as you go upwards, clouds form and precipitation occurs. Also, as you go upwards, temperature decreases. So they're cooler and wetter than the adjacent lowlands. And they're marked by a lot of variability, and they're also very changeable because they have a lot of different temperatures and precipitation occurring here that can change very quickly throughout a day and throughout the year. So we've been talking all semester about the atmosphere, and we've touched upon global warming and climate change. And one thing to discuss is that humans have always been playing a part in our environment. This isn't a new thing, but we have impacted the global climate for thousands of years. Indigenous people, Native Americans, they used fire in order to cultivate the land, to move throughout the environment, to scare out brush animals so that they could use them as food. So fire has been part of our environment for a long time. Some areas consider it natural, some consider it unnatural. Usually now the U.S. Forest Service tries to let fires actually exist within the forest until they become threatening to human being infrastructure. But they don't try and suppress all the fires anymore because fires are actually a part of the ecosystem. But when humans create fires, sometimes it gets more dramatic or more drastic. But it has been a part of the ecosystem and the climate for a very long time. People have also grazed animals for a long time. They use marginal lands. So these are the lands that are on the edge, the margins of an area. Humans often will use the easiest area to graze, so areas by rivers or streams. And so these areas got more of a population of grazing animals. So that's why it says overgrazing. They also have been extracting resources for thousands of years. Oil and coal and other types of resources that they extract out of quarries. This is not a new phenomenon. What is new is the rate that we're able to do these activities. We can do them at a much higher rate now, a much more globalized rate. And we consume a lot of energy through all the activities that we do. And you can see here on this chart that only 7% of our energy comes from renewable energy sources. Now this was from 2008. It may be up a little bit, but I doubt that it's up very, very much more from 7%. solar power, wind power, geothermal energy. These are all renewable sources of energy. Whereas petroleum and coal, they are sources of energy that have been created over millions of years. Once we extract them, they're gone. And we can diminish them and completely destroy our sources of that energy. And then nuclear power, it's a clean burning energy, but of course has many problems with nuclear meltdowns and radiation poisoning into the atmosphere. When we use certain types of energy, especially our fossil fuels, we release what are called greenhouse gases into the atmosphere. Carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons are released in the atmosphere. What they end up doing is they end up trapping the energy that is being released back out into space, and that ends up heating up our Earth, the greenhouse effect. Looking back to the 1800s, you can see that our temperature has varied, but ever since the 1980s, our temperature has been skyrocketing. About 1880 is when the Industrial Revolution is said to have started, and so our industries and our new inventions have enabled humans to use resources and use that energy at an increasing rate. So again, we talked about the greenhouse effect in previous chapters. The greenhouse effect is a process that occurs. It's the trapping of heat by the Earth's atmosphere due to the different wavelengths of radiation that are reflected back to outer space and trapped by particles in the atmosphere. This is a good thing and a bad thing, but it's kind of like Goldilocks. If you have too much or too little, you can't live there. It has to be just right. Global warming, on the other hand, is more of a debated concept. Global warming, the concept of global warming says that water vapor and carbon dioxide absorb heat and are responsible for the greenhouse effect of the atmosphere, and that burning fossil fuels has added great quantities of carbon dioxide to the atmosphere. And so, all of these things played together are causing our climate to change, causing it to warm up. However, climate change occurs due to a variety of factors that have been going on for a long time. Other things, such as the solar sunspots, could be causing our climate to change temperature. It could be a natural cyclical pattern from an ice age to a non-ice age. But what we have seen is an enhanced temperature increase with human industrialization. So, I leave you to figure out on your own, is global warming something you believe in? Global warming something that you want to try to stop? Something that you want to make changes in your life so that you can better the environment? And if you don't believe in global warming, are there changes you want to make in your life to better your pocketbook, to make yourself more economically efficient, and maybe possibly help the environment at the same time? Some of our possible consequences due to global warming are that we can alter the distribution of the world's water resources. We can change how much water is available in certain areas. We can also cause glaciers to start to melt. If glaciers start to melt, that water has to go somewhere, and it will cause the rise in global mean sea level, which might not seem like a big deal, except for if you live along the coast, as we do in New Jersey. If the global mean sea level rises, then the water will have to rise up and the coastal areas will be inundated with water. We also expect to see changing weather patterns. Not so much more hurricanes, but more intense hurricanes, longer duration, stronger hurricanes. We also expect to see a shift in the paths of the storms. So where they haven't been able to make it as far north before due to the westerly winds, they may now be able to make it into a different path because the winds aloft are changing due to a change in temperature. and also more extremes as we talk about with our climates. Climate takes into account the extremes of an area. Worse heat waves, worse droughts, worse snow. All of those things. More moisture, less moisture. Whatever extreme you're going in the direction of, that could happen due to global warming. So I leave you with this picture of a sunset out in Texas. I hope you enjoyed the meteorology section of the class, and I will see you again for astronomy.